Hello and good morning, everyone. It's Colin Knight here, and welcome to GSC Day 3. It's a lovely morning here. Hope you're all good, all fired up with coffee and breakfast. We'll just wait for the joiners to level out in about a minute or so, and then we'll crack on. This morning, we start with a session from Manik, and he's doing a session on encrypting data at rest with key label for DB2. Don't worry if you don't know much about this, because he's taking us through from the beginnings of that, which is good for me because I've heard a lot about it, but not really delved into it. So it's good that I'm going to get the full lowdown. Okay, Manik Kanth is a software engineer at Broadcom, and he's ready to go, I think. So hopefully without any further ado, Manik, we'll hand over to you. But before I do that, I should remember, there's a couple of things I need to mention. There are two charities GSC support this year. They are the Guide Dogs for the Blind and the RNLI. So please find those links to contribute if you can, because they're very worthy causes. And if we can get some good funds going towards them at the end of this session, at the end of this conference, that'd be really good. Real result for everybody. What I'll do is, if you want to ask a question, just put it into the chat and I'll moderate that, and we'll get those questions answered for you by Manik at the end of the session. And please make sure you do the feedback. It's the only way we can get better. So if you can do the feedback, just follow the link on the session in your agenda and put in your scores. And it should automatically fill in your own sort of registration number if you've got the My Agenda. Okay, without further ado, I've wasted too much time already. I'll hand over to Manik, and off we go. Thanks very much, everyone.
Thank you, Colin. Hello, and welcome to this virtual presentation titled Encrypting Data at Rest with Key Label for DB2 in zOS. My name is Manik, and I'm working as a software engineer for Broadcom. As we know, data has become the new perimeter of the enterprise and must be protected. No security solution can guarantee that a system is impenetrable and unable to be compromised. This is where taking the extra step of encrypting data comes into play. When we talk about encrypting data in mainframe, it is usually done via a feature of disk subsystem. One way to get this done is through the use of a zOS feature called zOS Dataset Encryption. This zOS capability can be used with DB2 11 or DB2 12 for zOS, but it got quite a bit easier to use with DB2 12 at functional level 502 or higher. Today, I will be talking about the basics of encryption, how encryption works with zOS datasets, particularly with the DB2 datasets. Then I will talk about key labels and key label management for zOS DFSMS dataset encryption. Various techniques like authentication, authorization, and encryption are available to protect data, but I will be focusing on encryption for today. Encryption is a way of hiding sensitive information in plain sight. Encryption operations require a cryptographic key and a cryptographic algorithm. Together, a cryptographic key and algorithm can encrypt and decrypt data. So what is the need of encryption? Have you ever thought why data needs to be protected, or how it could be at risk, and what can happen if data is compromised or leaked to a non-trusted environment? So there are like certain factors because of this happens, and one of them is like accidental data exposure. DB2 data is stored persistently in datasets. It could be possible sometimes someone who has no authority to perform SQL queries have authority to access the datasets that back the DB2 table and is able to read, view, or even copy those data. And this may result in the accidental exposure of data. For insider attacks, as we know, millions of transactions can occur an hour where all those credit card details are stored in the datasets. Storage administrators have the access to those data sets for creating, deleting, recovering, and it could be possible if they copy or transmit it to a non-trusted environment, then lead to like some insider attacks. There could be some data breaches as well, like security administrators ensure that non-sensitive data is encrypted. However, organizations can have thousands of datasets in their environment. So how can you verify that every location where sensitive data is might be protected or not? So this could also lead to some data breaches. There are some regulations in place to check the protection of data, such as European Union General Data Protection Regulation, well known as GDPR, Health Insurance Portability and Accountability Act, that requires organizations to protect sensitive data. These regulations impose sharp penalties for the disclosure of sensitive data. When you are planning for data protection, you must consider the entire life cycle of data from creation to destruction. You must know how it enters and exits your environment. So data at rest includes data that is stored in the datasets and files that are written to storage devices such as disk and tape. Data at rest can persist even when the associated application is no longer running. When the application is restarted, the application can retrieve the data at rest because it is stored on disk and tape. Data in use includes medical records that can be in memory before to being written to datasets and storage devices. Data in use is not persistent. However, it can be readable in system dumps. Data in flight includes passwords and credit card numbers that is sent over a network to authenticate a user to a server. For example, while making an online purchase. In the last, sensitive data. So recognizing sensitive data might not be difficult with formatted data, such as credit card numbers, social security numbers, and passwords. However, identifying all the places where that sensitive data is stored can be a challenge. Forms of encryption. There are like two types of encryption, symmetric and asymmetric. With symmetric encryption, the same cryptographic key is used for encryption and decryption. Symmetric encryption can be used to encrypt large amounts of data by breaking the data into blocks and encrypting each block. With asymmetric encryption, the receiver's public key is used for encryption and the receiver's private key is used for decryption. Because asymmetric encryption can be used to encrypt small amounts of data only, it often is used to encrypt symmetric keys. The encrypted symmetric key is then sent to a partner so that the communication between them can be encrypted with the symmetric keys. Standard cryptographic algorithms such as AES, DES, RSA are public and validated by mathematicians, cryptographers, and cryptanalysts. So now let's talk about the basic fundamentals of zOS dataset encryption. I'll begin with the cryptographic keys. Symmetric encryption and symmetric keys can be used to encrypt large amounts of data such as zOS datasets. Symmetric keys are created from random numbers that are generated by random number generators in hardware or software. The length of random number that is required for symmetric encryption depends on the encryption algorithm. Key management. Key management is a critical aspect in any encryption strategy. Cryptographic keys feature a lifecycle that includes tasks such as key creation, key activation, key deactivation, key archival, and key deletion. The basic purpose of dataset encryption is to limit the ability to access sensitive data. One of the many benefits of zOS dataset encryption is separation of duties between data owners and administrators. Role separation in general is splitting privileges between storage, security, and database administrators. Security administrator can define or alter dataset profiles to supply a key label for dataset encryption. It can define a security profile through the facility class so that key labels can be supplied through dataset profiles only. Storage administrator might have the authority to encrypt datasets. If permitted by the security administrator, storage administrators can encrypt datasets by supplying key labels in JCL or SMS data classes. IBM zOS Data Facility Storage Management Subsystem is required to implement zOS dataset encryption. For zOS dataset encryption, DFSMS supports the creation of and access to encrypted datasets, in addition to backup, migration, and replication of encrypted datasets. Applications that use the access method APIs can transparently access encrypted data if the user has the appropriate authorization to access the key label. IBM System Authorization Facility, well known as SAF, is an interface that is defined by zOS that enables programs to call system authorization services to check access to resources such as datasets and zOS commands. SAF is required for zOS dataset encryption. It provides the authorization interfaces for ICSF callable services and control user access to keys and services. SAF processes security authorization requests directly or works with Rescap or third-party security products such as CA, Top Secret, or ACF2 for zOS. IBM Resource Access Control Facility for zOS, known as Rescap, is an external security manager and a component of the security server for zOS that controls access to all protected zOS resources. Rescap or an equivalent ESM is required for zOS dataset encryption. A key feature of Rescap is its hierarchical management structure. The Rescap security administrator is defined at the top of the hierarchy and can issue any Rescap command, or it can change any Rescap profile. With the zOS dataset encryption, you can define Rescap profiles to assign ICSF key labels to datasets and authorize users and groups to ICSF keys and services. zOS dataset encryption supports encrypting data in bulk by using DFSMS access methods instead of encrypting a single field or row at a time. zOS dataset encryption is intended to be more accessible to the organization than many other forms of encryption. For example, it is not apparent to the application and requires no changes to application code. It performs efficiently at speed by the use of the integrated Z crypto hardware and software stack. It enables encryption without requiring application or database changes. It also supports encrypted data throughout its journey. For example, with zOS dataset encryption, any data that is replicated by using peer-to-peer remote copy or extended remote copy, backed up or migrated, remains encrypted. zOS dataset encryption provides cryptographic separation from other environments. Encryption keys can be configured so that they are owned and managed by a logical organizational environment. For example, production versus test environment. One of the many benefits of the zOS dataset encryption is separation of duties between data owners and administrators, as I said earlier. IBM Z cryptographic system. zOS dataset encryption uses the integrated cryptographic system that is available on the Z platform. The encryption algorithms are public while the encryption keys are kept secret. The secure management of keys is vital to the protection of data in the cryptographic system. zOS dataset encryption relies on encryption keys that are in a key store, such as cryptographic key datasets when datasets are encrypted or decrypted. Those encryption keys are managed by the zOS Integrated Cryptographic Services Facility. ICSF, each encryption key includes a corresponding key label. The key label is used as a handle to locate the encryption key within the cryptographic key dataset. The IBM Z platform offers cryptographic engines that provide high-speed cryptographic operation. Central processor assist for cryptographic function is provided through a set of instructions that are available in hardware on every processor unit. Crypto Express adapters cryptographic function is provided through high security, tamper responding hardware security modules. Cryptographic key dataset is a key store for storing the secured symmetric keys. The keys generated by ICSF are stored in cryptographic key dataset under respective labels known as key labels. Integrated Cryptographic Services Facility has the generated master key. It communicates directly with the Crypto Express card and CPEC-F. It passes protected keys to CPEC-F for decrypting data. It could also control access to the TSO panels. Encryption keys. zOS dataset encryption processing uses different type of encryption keys. I'm going to quickly summarize all of them. Data encrypting key is used to encrypt and decrypt data. Data key, a type of data encrypting key, is in zOS dataset encryption supports only data keys that are created by the using the AES algorithm that includes a 256-bit key length. Key encrypting key is a key that encrypts or wrap other keys. Master key is a special key encrypting key that is in a tamper responding Crypto Express adapter only and sits at the top level of a key encrypting key hierarchy. Master keys for all algorithms are stored on the Crypto Express hardware card in its hardware security module. CPEC-F wrapping key is a special key encrypting key that is generated at LPAR activation and is in the hardware system area, which is inaccessible to applications and the operating system. It is used to create protected keys. Secure key is a data encrypting key that is encrypted by a master key or key encrypting key and never appears in clear text. That is outside of secure environments such as a tamper responding hardware security module or Z firmware. Secure keys can be stored in an ICSF key dataset or returned to the ICSF caller. Clear key is a data encrypting key that is not encrypted by any other key. The key material is in clear text. Clear keys can be stored in an ICSF key dataset or returned to the ICSF caller at key creation. Protected key is a data encrypting key that is encrypted by a CPEC-F wrapping key and used within the Z platform. Although protected keys are cached in ICSF, they are not persistently stored in an ICSF key dataset. Protected keys can be returned to authorized ICSF callers such as DFSMS and Db2. Operational key, in the last one, is a key that is not a master key such as a data encrypting key which can be cleared, secure, or protected. Basically, generating data encryption keys as secure keys and storing them in the cryptographic key dataset is the most secure method of protecting key material on the Z platform. This process requires the use of a crypto express adapters. When processing encrypted datasets, the FSMS access methods use only protected keys to ensure that the sensitive data keys are never available in clear text within the operating system. So let's learn how the basic zOS data encryption works. zOS dataset encryption allows you to identify new datasets or groups of datasets to be encrypted. This process is done by using SAP controls or Rescap and SMS policies. You can specify key labels to identify encryption keys such as secure keys that are in the cryptographic key dataset. When an encrypted dataset is created, the key label is stored as an attribute of the dataset in the catalog. Authorization to view the contents of a dataset is based on access to the key label that is associated with the dataset. The encryption key that is associated with that key label is used by the FSMS to start CPACF to encrypt and decrypt the data. Encrypted datasets must be extended, formatted, and cataloged. A dataset is defined as encrypted when a key label is applied on allocation of a new sequential or VSM extended format dataset. You can supply a key label by using keywords in any of the source formats using the following order of precedence. Like the first one is data facility product segment in the Rescap dataset profile. Second would be JCL or with dynamic allocation, TSO allocates or IDCAMs define, and the third one would be the SMS data class. Key labels. Basically, the length of a key label is less than or equal to 64 characters. The naming convention is quite similar to the dataset naming convention. So, like the first character can be a number or period. Other characters could be from A to Z, 0 to 9 or alphanumeric characters. Key label is a key to cryptographic key dataset and is stored as dataset attribute in the catalog, as I said earlier. Sequential datasets with block size less than 16 can't be encrypted. When the key reaches the end of its validity, the archived data could either be re-encrypted or destroyed. When a key is used outside its validity range, error message S213 and return code 8 with the reason code appears. SMS record 82 to 40 display keys crypto periods, and SMS records 80 to 30 display failed attempts to use expired or archived keys. The key labels are used for dataset in the following manner. In JSIL, you can define it by using parameter DS key label with the appropriate key label name. With the dynamic allocation, you can use it with the text unit. With the TSO allocation, you can provide the DS key label name, or you can use the IDCAMs define to define that key label with the appropriate name. With the DFSMS data facility product profile in Rescap, HF to TSS, or in the SMS data class. This is how the key labels are used for datasets. This example shows how a key label is used when an encrypted dataset is created. It uses a key label that is specified in the DFP segment in the Rescap dataset profile. First thing would be the DFSMS calls Rescap to determine whether a key label is supplied in the DFP segment in the Rescap dataset profile. Then DFSMS validates the key label syntax. It creates an encryption cell that is associated with the dataset and stores the key label in the encryption cell. It should be noted that we are not calling CryptoExpress nor CPACF during dataset create processing. This next example shows how the key labels and different keys are used with the zOS dataset encryption. This example uses secure keys that are stored in the cryptographic key dataset and involves input processing of an encrypted dataset. For the dataset open call, DFSMS receives the key label that is associated with the dataset from the catalog and calls Rescap to verify the user's access to the key label. After that, DFSMS calls ICSF with the key label. Now ICSF obtains the secure key from the cryptographic key dataset and calls the CryptoExpress 6F to unwrap the key. With assistance from firmware, CryptoExpress decrypts the secure key and rewraps it with the transport key. The wrapped key is sent to CPACF with the assistance from Z firmware. CPACF unwraps the wrapped key with the transport key to expose the data key. Now the data key is wrapped with the CPACF wrapping key to create the protected key. The protected key is sent to ICSF where it is cached in protected memory for future callers. ICSF sends the protected key to DFSMS to encrypt and decrypt data. For dataset read and get option, DFSMS reads encrypted data from dataset and starts CPACF, which passes the protected key. CPACF decrypts data by using the protected key. Decrypted data is sent as a clear text to the application through DFSMS. So basically, this is how it's done. Key label management for zOS DFSMS dataset encryption. Function level 502 introduces management of key labels for zOS DFSMS dataset encryption to transparently encrypt Db2 datasets. DFSMS can be used to encrypt various types of Db2 datasets, including Db2 managed tablespace and index space datasets, datasets that are used by Db2 utilities, and sequential input and output datasets. Db2 log, catalog, and directory are encrypted through setting a key label for underlying datasets. The following are permitted to use key labels associated with the Db2 dataset. Db2 started task user ID, any user ID that is required to read or write to an encrypted dataset, any user ID that is required to run any of the standalone utilities. Key label used to protect Db2 dataset is defined on all the members of a data sharing group, any backup systems that might read or write from an encrypted dataset. Db2 managed index and table spaces are encrypted, decrypted by running either of the following utilities. It could be Reop Tablespace, Reop Index, Load, Replace, Recover, or Rebuild Index. So Db2 dataset encryption for the Db2 system objects, that is logs, catalogs, or directory objects. Db2 supports zOS DFSMS dataset encryption for log, catalog, and directory datasets using a key label for encryption and decryption. You can define a key label in the following precedence order. You can define a key label in the data facility profile segment of Rescap dataset profile. You can define a key label using encryption key label system parameter that was introduced with function level 502 with version 12. You can set a key label using IDCAM defined for active logs, or you can set a key label in the DFSMS data class. With the function level 502 to trigger the encryption, you can set the encryption key label subsystem parameter value, then issue the set syspam command to cause the encryption key label subsystem parameter to take effect. Db2 passes this encryption key label value to DFSMS for allocation of a new archive log dataset or catalog and directory datasets. If a key label is specified in the Rescap dataset profile, the key label overrides the Db2 provided key label. You can run the Reop Tablespace utility against the catalog and directory tablespaces. Allocated new active log dataset as encrypted. The user who allocates the active log dataset must specify a key label that Db2 has permission to use. However, the user who allocates the active log dataset is not required to have access to that key label. You can identify the encrypted dataset as the new active log using one of the following methods. You can issue the stop db2 command, run the dsnju003 new log statement, and restart db2 to enable the use of encrypted active log datasets. Or you can issue the set log new log command. The active log dataset is immediately available for use without recycling db2. On the basis of the key label setting, new archive logs are automatically encrypted. For auditing or to display current key label information, you can use display archive command as it displays current key label information for archive log datasets that are in use, or you can use display log command as it displays current key label information for current active log datasets. Report tablespace set utility also displays key labels associated for each catalog, directory, and user tablespaces using the new show key label option. So encrypting user objects. Db2 for zOS supports zOS DFSMS dataset encryption for the dataset associated with the user objects. You can define a key label used by Db2 in the same precedence order, like defining a key label in the DSP segment, or you can define a key label using next SQL query, like create, storage, or alter table query that was introduced with the function level 502, or you can set a key label in the DFSMS data class. The procedure to do is like you need to obtain a key label from the Rescap ICSF administrator and ensure that the key label is defined on all the backup sites used in disaster recovery and all the subsystems in a data sharing group. So you can issue a create or alter storage group statement to define a key label. Db2 provides the specified key label to DFSMS when allocating new datasets within the storage group. To override the Db2 provided key label at a table level, use the create table or alter table statement with the key label clause. This table level override is only available for tables in universal or partitioned table spaces. It also includes explicitly or implicitly created base table space, auxiliary table spaces, XML table spaces, and index spaces. The key label specified in the Rescap dataset profile overrides any Db2 provided key label. You can issue the Reop Tablespace utility against each tablespace within the storage group. The key label that is specified in the alter storage group statement is provided to DFSMS when allocating new datasets for the table spaces. To change a Db2 dataset from encrypted to unencrypted, you need to set the subsystem encryption key label parameter to blank, or then set syspalm command for the zpalm value to take effect. Db2 doesn't pass the encryption key label value to DFSMS for allocation of new datasets for archive logs. You can run the Reop Tablespace utility against the catalog and directory tablespaces. To change the user object from encrypted to unencrypted with the function level 502, you can issue the alter table or alter storage group SQL query with the no key label clause. Then you have to run the Reop Tablespace utility against the tablespaces. So this is how you can change the Db2 dataset from encrypted to unencrypted. So let's quickly summarize what we have learned so far. With zOS dataset encryption is transparent and is enabled by the policy. The host encryption via CPAC as data written to or read from disk. It supports sequential and extended format vSAN datasets. It encrypts Db2 datasets that are system objects like active and archive log datasets, catalog, directory, and then user objects. It is supported in Db2 version 11 and version 12. Version 12 function level 502 adds DBA controls. Data in the buffer pool is not encrypted. Here is some miscellaneous information I thought could be useful. So users must have guaranteed security access to the key label used to encrypt and decrypt datasets. Otherwise, insufficient access authority message is displayed. Db2 address space in any utility user must have at least read authority to the resource in Rescap facility. This one. You can set the universal access parameter to none, a way to disable encryption for those who are not explicitly authorized to use it. The storage administrator works closely with the security administrator and ICSF administrator to ensure that all necessary datasets are protected. The storage administrator might be responsible for data migration, backup, and replication. They can perform this function for encrypted datasets without requiring authority to the key label because these functions process the data in the encrypted form. Something about the cryptographic administrator, the cryptographic administrator governs the cryptographic system and keys that are used for dataset encryption. The responsibilities of the cryptographic administrator include generating and managing master keys and generating and managing operational keys. This role can also involve monitoring the use of Crypto Express coprocessor and CPAC-F. With zOS dataset encryption, you can reuse dataset resources, profiles, or create more granular resources or profiles so that you can assign different keys to different applications or business areas. For example, if you have a resource profile, suppose product application, this dataset name, and you can assign a single key label to cover all datasets that are protected by that profile. However, if you want to ensure that certain information is available to only a subset of users, granularity can be added. You can define more granular resources profiles such as product application accounts and product application banking, different qualifiers, but the high level qualifier should be the same, and associate a different key label with each resource profile to enforce separation of access to information associated with the application. So these are the links and references I have used to create this presentation. So this concludes this session. I hope I was able to give you some valuable information about the process of encryption and how it works with the Db2 datasets. Please feel free to write me on my email, manik.kant@broadcom.com if you have any questions, or you can ask it right away after this session. Once again, thank you for attending my session. You can use this QR code to give me some feedback. Thank you.
All right, thanks very much, Manik. I think there was one question which I think you answered in the chat. I don't know whether is that okay for you, Darren? Or have you got a supplemental question on that? Oh, there's another question popped up. Okay, for Db2 zOS, if the user object datasets are encrypted, can the access to users be granted at BACF profile level?
Yes, it could be.
That's a very easy answer there. Thanks.
You just need to
Manik.
get the key label from the Rescap for security administrator, and then you can use that key label to encrypt the user objects. So.
Darren wants to elaborate on his question. Let's see if I can unmute Darren, if that's all right. And then, is that all right, Darren, to ask your question? Let's see if we can do that. Hello, Darren. Welcome aboard. What's your question? It's like swap shop. This is.
You can hear me, right?
Yes, very clear.
Oh, okay. Yeah, that's thanks for the presentation, Manik. That's what we found in our test systems is that there's a different access that is being checked between the first access when the user opens the dataset versus any other future access. So it's only the first user that needs special access to CSF KRR2 key, while any subsequent user using the same dataset but not opening it for the first time is not put through the same check.
Okay. This one is something new for me. Can you can I get back to you on the email later? Because I need to verify it on my own, then I can get back to you. It would be nice if you can
I'll just put the related information over there, which says access to that particular resource is different between the first time any user opening that data set versus the second time that any other user might come. That access is not being checked for that user. So we're not able to predict which one. Yes, if you can get back to us.
Would it be a good idea, Darren, if you emailed Manik directly, and then you can give him the detail of what you mean with that? I think if you can pass the details to an email, I think that'd be really good. Is that okay, Manik, if he does that?
Yeah, sure.
Okay. Any other questions? We've got a few minutes left. If there aren't, if there are,
that's okay.
Sorry, Darren.
I got a couple more, if that's okay.
Well, nobody else is asking, so your spotlight's on you again. Go for it.
Okay. Any documentation that you come across, Manik, which details the performance implication, sequential access or direct access or prefetches, that kind of information. I didn't find too much information on the performance side of things.
Darren, I have to say sorry, because I'm not your voice is not clear to me. There is something couldn't hear you well.
So Manik, I got the gist of that. So Darren's asking if there's any sort of documentation or any maybe red books or papers on performance of the encryption process and de-encrypting, I guess, out there.
Yeah, there are some, and I can provide it to you via the email. That is the documents I've studied to create this presentation, so I can just forward it to you later. Yeah.
That's great. Thanks very much, Manik. Anything else? There's nothing on the chat at the moment. So there's no questions coming through. Yes. Okay. So Darren's just saying that he has found. So I guess it was a loaded question about performance. He's found some difference between Z14 and Z15 performance. So I guess that's the interesting subject, is why should there be a difference between 15 and 14 apart from 15s are faster? Okay, let's see if we can find out that as well.
That is interesting. Like I haven't tried on Z15, but seems interesting to me.
Yeah.
Look at it.
Thank you. Anybody for anything else? No. Okay, I think it's all gone quiet now. Thanks for those questions, Darren. Thanks for a great presentation, Manik. That was really good. I've written down quite a few notes myself, so I've got a few things to probably follow up. So yeah, that was really good. Please do follow the feedback link. If you need the session ID, it is 7AG. But there should be a link in your build your own agenda, and there should be a link just at the bottom of the agenda item. So the next session for DB2 is about squeezing data, a history of compression of data. So that comes up at 10:30. So you've got 45 minutes or so to get a coffee or whatever, catch up on any news, and join that session at 10:30. So thanks very much, Manik. Please do get your feedback in, because that's the only way we can all improve the process. And also, if you get a chance, please do support those two charities that GSC sponsored. It's the RNLI and Guide Dogs for the Blind this year. Thanks very much, everyone. I'll close down the session now, and hopefully see you back again at 10:30. Thanks, everyone. Catch you later.